Let's go through this study guide. We'll do the vast majority of the proofs at the end of it.
Thank gosh.
Yeah.
That takes so long.
Some of them took a little bit of time, but that process that you went through, if they genuinely took you a long time, is important. Like getting the practice of doing those proofs before you see what you see tomorrow.
Wasn't there 8 of them?
There's a lot of them. I don't know. Yeah.
No, there was 8.
Something like that. You guys are ready now. You are ready. All right, numero uno. Kalia, you did number 1 for us. What type of angle are we working with in number 1, Kalia? It's an exterior angle because it's outside of my triangle, okay? Now, Kalia did an awesome job of writing this on the board. I'm also going to write it in here. That way, anyone that ends up watching the video can see what we need to do in order to solve it. So tell us what you did, Kalia.
I added the 2 angles inside and then make them equal to the one on the outside.
Good. We call those the 2 remote interior angles. So the 2 angles that are not connected to that exterior angle, add those together, set it equal to your exterior angle. Good. And then you got x equals 25. We need a name for the theorem, though. What theorem are we using, Kalia?
Exterior angle theorem.
Very good. Perfect. All right, cool. Miss Molly, you did number 2.
Yeah.
If I told you guys that it's 65, I'm sorry. It should be 55. I will make sure that the test is printed better. This just came from a document that I printed. What are you looking for? You good?
Yeah, there's carriages on one. Is it not?
Wait, is it 55 or 60?
It should be 55. And then the coefficient in front of that set of parentheses should be a 5.
I looked right at this, I swear.
It's all good. Isn't that the third one I've given you?
It is, yeah.
Okay. All right. Molly, what'd you do?
I lost 5.
Shh.
And 3 plus 5 and I equal 55.
Very good. So you knew that because of...
They're like 50 angles.
Right. So these 2 sets of angles are congruent. So that means the third set of angles, by third angles theorem, would have to be congruent. So that's the name of the theorem you use, is third angles theorem. And then Molly sets them equal to each other and solves. So 55, and then you set that equal to 5 times 3x plus 5. And then what'd you do after that, Molly?
And then I distributed
Cool.
5 and I got 15x plus 25 equals 55.
Which gave you 30 equals 15x after you do that subtraction, which tells you that x equals, good job, Molly. All right, cool. In the diagram, those 2 sides are congruent. What 2 angles would be congruent? No one did this, so you guys tell me, number 3.
Angle R and angle S.
Good. Angle R is congruent to angle S. All right, and then what about number 4? What type of triangle do we have?
Equilateral.
Okay, so if it's equilateral, that means it is...
Equilateral.
The reason why I bring that up is because 2x is an expression for an angle. So if all the angles are the same, what does that mean?
They're all 2
All 2x.
Cool. So 2x plus 2x plus 2x equals 180.
Yeah.
Okay. 6x equals 180. Divide by 6, you get x equals 20. Other route you could have taken, you could have just set 2x equal to 60 and then divide by 2. Oh, it should be 30. That's my bad. Math is hard.
I agree.
Should be 30. Looks like a 36, but 30. Okay, cool. All right. 5. No one did 5. You guys tell me what type of triangle do we have?
Isosceles.
These 2 sides are the same. So then those are addition signs.
Those look like division.
Yeah, but like we never put division.
I mean, you never know. You gave us the homework yesterday with 8 proofs on it.
Oh, man. That was pretty good. I also gave you a lot of time in class.
Yeah, that's fine.
So then you solve for x, you get x equals 3. Subtract 3x from both sides. Subtract 12 from both sides. You get x equals 3. Okay. All right. Now 6. We put up. Who did 6? Miss Emma. All right, Emma, what type of triangle do we got? Cool. And we have an expression for all 3 sides. So pick 2 of your favorites and set them equal to each other, right?
I added all of them.
Ah. Oh, they're angle measures. That's my bad. So add them all up and set it equal to 180. That's exactly what you should do. Your other option is just pick one expression and set it equal to 60. Either one would be perfectly fine. But Emma added up all those values and then set it equal to 180. What did you get, Emma? Good. Other option would be 15x plus 15 equals 60, because if all the sides are congruent, all the angles would be 60. And then you would get 15x equals 45 after you subtract, so you get x equals 3. Either one of those options is perfectly fine. Raf?
How did you get 60?
All the sides are the same. What does that mean about all the angles?
They're the same.
So if they're all the same, Oliver's right. If you do 180 divided by 3, you get 60 degrees. That's also like a fact that we've been throwing around for the past week or so, is that if I know all the angles are the same, every angle has to be 60 degrees. Because 60 plus 60 plus 60 equals 180.
Oh, okay.
Is it clicking now?
Yeah.
Oliver?
Wait, so what's the scenario where you pick
Parker, close your iPad.
two of the sides instead of equal to each other? Like, why could you do that with something else and not here?
Well, so 5, we could have done that here, Oliver. You should get the same answer. Because these are angles. But even still, we know that all those angles are the same, so that's something else you could have done. You could have set 17x plus 9 equal 15x plus 15.
And you get the same thing.
Yes. So you would get 2x equals 6, and then you get x equals 3.
Okay.
So either way would work just fine. Okay? All right. 7 says prove those triangles are congruent. What am I going to have to do to prove those triangles congruent?
Distance formula?
How many times?
6 times.
Barf. That's a lot.
Sure is.
Yeah. So if you do distance formula 6 times, you come up with a distance for each one of the sides, and then you're checking to see that each one of the sides are congruent. Each pair is congruent. And then once that's the case, then you can say that the triangles are congruent to each other. Even though it says prove, you don't have to write a 2-column proof for that. You just have to do distance formula a bunch of times. You will have to do distance formula on your test tomorrow, but the context will look like this. I'll give you a triangle with coordinates, not on a grid. It'll just be like, coordinate A is at 0, 5. Coordinate B is at 2, negative 3. And then coordinate C is at 3, 6. And it'll say classify the triangle based on the sides.
Are we going to get the distance formula?
I'll write it on the board. Just remind me and I'll write it on the board for you guys. Okay? Because you get it on your state test. So anyway, that you'd have to do distance formula 3 times. What would you be looking for if you're trying to classify the triangle based on the sides?
Or maybe like congruent, like it's isosceles.
Good. Isosceles, scalene, or equilateral. Okay? You guys want me to do a distance formula 1?
No.
All right. 8 is on the backboard, and a very good problem as well, too. So 8 was a combination of, who did that one? Haley and Brielle. All right. First one. What'd you guys put?
SAS.
I like it. That angle is between the 2 sets of sides that you know, so textbook SAS. What about B?
No, because SSA is not a valid reason.
Good. That angle is not between the sides, and there's 2 sides in an angle, so it would be angle side side, or side side angle. But either way, that's not a thing. The only way that angle side side works or side side angle works is if it's what?
Or an angle.
Making it which proof technique?
HL.
HL. Very good. So side side angle only works if that angle is a right angle, and then it's HL theorem instead. We'll do an HL theorem proof today. What about C, ladies?
Not a clinical.
They give you a pair of angles. You could also get the reflexive side, right? But that's just 2 pairs of information, not 3. So then that's not enough. All right, what about part D?
SSS.
Good. We got that reflexive side down Main Street, so side, side, side is what we would use. Yes, ma'am.
On B1, side angle.
You said on B.
Yeah, there's like 2 sides in an angle, or 2 sides like. Because it supposed to be in between the sides.
So the angles that I would want for that, Alina, would be this angle and that angle. If I knew that angle, then I could use side angle side.
Okay.
Make sense?
Yeah.
Okay. All right. 9, 10, 11, and 12. You guys had problems like this on your quiz and struggled with it a little bit. So I want to make sure I go over this. Okay. All right. So for number 9, it says, given that those sides are congruent, use the picture and what additional piece of information would you need to use HL theorem? Okay. Don't just tell me a side. Don't just tell me an angle. You need to tell me what side specifically or what angle specifically. So I'm going to mark up my picture and then erase it each time. So if I know BC is congruent to EF, I have that these are right angles. What additional piece of information would I need to prove these triangles congruent by HL? Let's go through my checklist for HL. Have I listed my hypotenuse as congruent? No, so that's what I need. I would need to state that AC is congruent to DF. Okay? I have a pair of legs congruent. I have that they're right angles and they're right triangles, so that would be fine. All right, let's reset my picture. Given AB is congruent to DE, so AB congruent to DE, and AC is congruent to DF, how could we prove these triangles congruent using side, side, side? What additional piece of information would I need?
Another side, EC is congruent to EF.
Good. So don't just say another side, but tell me specifically with letters. But Rafa, you're right. I do need a side. That side is BC is congruent to EF. All right. Okay, reset my picture. Given angle A is congruent to angle D, and angle B is congruent to, angle B is congruent to angle E, which is kind of already marked. How would we prove them congruent by angle, angle, side? This one's a little more open-ended. You have a choice of two things that you could put here.
Angle E is congruent to angle F.
That would give me angle, angle, angle.
But AC is congruent to DF.
Good. You could do AC congruent to DF. Your other option would be to say that BC is congruent to EF, would also be an acceptable answer. Okay. All right. Given angle A is congruent to angle D, and angle C is congruent to angle F, how would we prove them by angle, side, angle? What other piece would I need? So if I wanted to do it by angle, side, angle, what would I need?
AC congruent to DF.
Good job, Mallory. I need the side that's between those two angles because I didn't say anything about side yet. So I would need AC is congruent to DF.
Yeah.
Again. Which Disney movie is that from? Little Mermaid. I didn't watch that till I had daughters. Which is the case for most Disney movies for me. All right, find X, state which theorem you use to find X. This one's pretty simple. Carter, tell us about it, bud.
Wait, for which one?
13.
Oh.
You did this one.
I basically just like add them all up and equal it to 180 and then just solve for X.
Good. So 4x minus 5 plus 3x plus 5 plus 40 equals 180. And then Carter combined like terms, solve for x, and got x equals 20. And then the equally important part, what's the name of the theorem?
Triangle sum theorem.
Cool. Triangle sum, triangle angle sum. As long as you write either one of those, then that would be fine. X equals 20, triangle angle sum. We can do better than that. Triangle angle sum theorem. All right, 3 ways to classify triangles based on their sides.
Isosceles, scalene, and equilateral.
Good. What's it mean if a triangle is scalene?
Oh, it's just
No
Yeah.
congruent sides.
Good boy.
What's if it's isosceles?
Two of the sides.
2 congruent sides. Equilateral.
Oh, all sides.
Good.
Yes. You're so
All right, how do we classify triangles based on their angles?
Obtuse.
obtuse.
I like it. What else?
Q.
Q.
Okay.
Right.
Correct.
Straight.
No.
That's not right.
No.
Isn't it like equal?
Equal.
Angular. You're talking about classifying angles, Carter.
So what do we classify?
Triangles based on their angles?
I don't like how it's spelled.
That's so not fair.
Triangular.
That little division right there? Equiangu. I just don't like it.
Is there a unit? Wait, I'm right here.
Equiangular. If it's acute, what's that mean?
It is less than 90.
3 acute angles.
What?
triangle. If a triangle's acute, it has 3 acute angles. If it's obtuse, what does that mean?
Something about 180.
1 obtuse angle.
Wait, if a triangle is acute,
Then it has 3 acute angles.
I feel like that's not true.
It is.
How?
60 plus 60 plus 60.
Yeah, but that's equal.
Okay? 70 plus 50 plus 60.
But couldn't you do 120 plus 40 plus 20?
Yeah. That would be an obtuse triangle then, because that 120 degree angle is obtuse.
Oh, yeah, you're right. Fine, I'll give it to you.
Thanks. If it's right, it has 1 right angle, and then if it's equiangular,
All of them
good, 3 congruent angles.
are. Wait.
Raphael, if it's 3 congruent angles, what do all of them measure?
60.
Good.
Is
that right?
Wait, would AA work for equilateral?
AAA?
Equilibrium triangle or whatever?
Equilibrium.
No.
equilibrium.
You gotta have a side in there
Alright,
to
if
constrain your
it's
values.
Equal, triangle.
Yeah, that means all the angles are.
You said
If it's equilateral, is that what you're saying?
Yeah.
Then it'd be side, side, side.
Then, actually, it'd be
Angular.
angular length side, side, side.
Huh?
Wait, how can angle just not work?
Yeah.
Why would angle, angle, angle not work?
Because it could be bigger.
I just like want to understand. So I don't want to get lost in the test.
Not the same.
All right. I'll do this really briefly.
Is that a 3D?
Pencil sharpener in the back.
Let's say this is an equilateral triangle.
Yes.
All 3 sides are the same, but we don't really care about that. All the angles would be the same, right?
Yeah.
Okay. What if I took this, boop,
Oh yeah, I remember that. But like, what if there's
copy,
two triangles next to each other that look the exact same?
pasta, mwah, mwah.
She's doing this.
Okay. Did the angle measures of those triangles change?
No.
Yes. No.
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 Did the side lengths change?
Yes.
So are they congruent?
When you have like the two.
No.
Look, if
That's
you
why
have-
angle, angle, angle doesn't
When
work.
you have like the two triangles next to
Oh,
each other,
that's smart.
you can tell that they're not the same.
Fine, I'll give that one to you too.
But tell me how this angle side to side doesn't work.
Mr. Pierre,
I showed that applet already.
Mr. Pierre, are you tough at basketball?
I'm the worst. Genuinely the worst. Any other sport, pretty good at, except tennis. Not good at tennis. Horrible at golf. I'm not good at a lot of sports, it turns out. But no, I'm very bad at basketball. I'm good at other sports, but not that one.
Like what? Besides like running. Like actually.
Like math.
I love baseball.
Are you good at baseball?
I played football.
You played football
I did.
in high school?
Yeah.
What position?
Wide receiver, cornerback.
Did you start?
My freshman team.
Or did you not play after that?
No, I didn't, because I'm built like this. So I just didn't. But
Built like a beast.
there it is. Thanks, Parker. You got to gas me up after spilling something in my class. All right, proof time. You guys ready? Well, you brought it, so I'm still mad at you.
Has to be a lot of things.
Very bad at basketball.
You should be the coach for football.
No, not at all.
JVC.
I coached cross country in the past. I would coach cross country again, but I'm a rabbit.
Is he really?
I'm not good. I can't do it anytime soon though. Like I got too many kids. All right, here we go.
He's like old. He's like that.
Oh yeah, I know who you're talking
He's
about.
so Gilbert. His name was like, it was something weird. Mr. Ross.
Okay, this is a good proof because this one's tough. This is a hard one. This is one of the harder ones that are on this sheet. TUFF, is that what you said? Okay. Hey, they don't give you any congruence pieces in your given. They just give you what?
5, 6.
Yeah, they just give you vocab words essentially, right? Carter, close that iPad. DF bisects angle CDE. What is being bisected? A side or an angle?
An angle.
An angle. So what do I get from that?
Nothing. Or, something.
You get 2 congruent pieces, right?
Yeah, sure.
Boys, stay with me.
I'm here.
An angle is being bisected. From that, we get 2 congruent angles.
Yeah.
Which 2 congruent angles?
DF bisects.
So DF bisects CDE. So CDE is up here.
I guess you get CG equals EG.
And it's an angle, so we need 3 letters.
Oh, you get CDG
Okay?
is congruent to EDG.
Okay, so we list that.
Ooh.
What is that G?
It turns out I'm not good at writing G's.
I love it.
Either,
It's so fun.
I'm not good at writing bids.
Turns out. Reason.
Definition
Definition of angle line.
Nice.
Okay. If you don't have these filled out, please fill them out. Bryce, close the iPad. All right, so that gives me a pair of angles congruent. I still have two things to find before I go anywhere else, okay? All right, what else do I know?
You know that CE is perpendicular.
Okay, if you are given that lines are perpendicular, what do we get from that?
Get two
Right angles.
right angles. Okay, so then
Angle, and let's look at what my right angles are. So CE and DF, so then my right angles would be right here. So then I would say angle CGD,
CGD
comma, angle EGD.
are right all are right angles,
Good.
and that would be
Right angle theorem.
no perpendicular definition of perpendicular.
Good job, Carter.
Yeah, you know, my thing.
Okay, I didn't say they're congruent. I just said that they're right angles,
Yeah,
okay?
but now you can.
My proof goes one of two ways from here. Either I'm going to do something with angles, or I'm going to do HL theorem.
You're gonna do something with angles.
Yeah, yeah. I'm not going to use HL. Why not?
Because it wasn't a given.
Like, they didn't tell me anything about my hypotenuses, and I can't get those to be congruent to each other. They didn't tell me anything about sides. So I don't have the right pieces I would need for that, okay?
So now would you put that triangle, like the triangle?
I'm not going to state that they're right triangles. It's a good question. I only do that if I'm going to use HL theorem, okay?
So you just put the reflexive?
I will put reflexive in a second, but there's something I need to
Oh,
put.
you have
But
to put that triangle CDG is congruent to the triangle.
not triangle. I'm going to say that those angles are
Angle,
congruent.
Oh, yeah, angle.
So I know that they're both right angles. So now I'm going to say that angle CGD is congruent to angle EGD. I apologize for my G. Why can't I draw a G?
If you're white, draw like that.
One, or could you switch 2 and 3? Like, does it matter which one?
Yeah.
you do that with?
Yeah, that's fine. You can reorder those. That's fine. Reason for that would be right angle congruence theorem. That's how I know that the right angles are congruent. It's annoying, but you do have to state that they're right angles after you state that they're perpendicular.
It's kind of mean they gave us this long proof with not one of them.
It's because I care about you guys.
Seems like.
All right, so then I have that those angles are congruent. But Carter, you mentioned what else do I need to put?
That they're reflective.
So GD, there's another Hall of Fame G right there, is congruent to GD, reflexive property.
Whoa.
That looks like a B.
I am 34 years old. I don't know how to write a letter G.
Then you're done.
Hey.
Yeah.
Mr. P,
What?
you know what angle 9 looks like upside down?
I don't want to know anything that you're saying right now.
So right angle 9 and rotate it. So it's upside down.
I don't know. I feel like this is some
Please just.
grade
It
school
won't be
BS that I don't care about.
It won't be bad.
You're gonna care.
No, you're gonna care. All right, what proof technique am I using here?
S.
Angle side angle.
Angle side angle. Yes.
It just makes 6 7 by the way.
Does it?
Yeah, do it.
What is it again?
Angle 9.
Angle 9.
Hold it up.
And just like try to turn your head.
Turn your iPad up.
Turn the pad.
Yeah, turn the pad.
No. How do I just select?
You have to watch it.
Bop.
Lasso it.
You got this?
Is there a rotate?
I think you just have to do it yourself.
Translate? No.
Just like try to like turn
Just flip your iPad.
it. Yo!
You guys are so dumb. You're so dumb. Oh man, that's on recording. All right, number 17. Here we go.
Get along.
So dumb.
I love these jeans. I like it.
Oliver goes, you're gonna care.
These are cute. I like that they got these for pencils. Are these the ones we got when we got in the corner? Yeah. Okay.
Are we going over this thing the whole time or are you gonna give a seminar review?
I won't give you much time to do your review. It must be done out of class. I just want to make sure I go through the vast majority of these proofs with you guys. This is a good one as well, too. I always like proofs that have parallel lines, because it's something we spend a decent amount of time on, so I like those ones. Okay, I know that AD is parallel to BC. I know that they are also congruent to each other, so I have a pair of sides there. There are so many triangles that are in that picture. So it's important for us to kind of hone in on, or at least pay attention to, which triangles we're trying to get. So real quickly, I'm just going to say AED, just kind of highlight those. I'm not going to keep that in there, but at least in my mind, I look at which two triangles I'm trying to get, okay? Okay, you guys tell me, if you know lines are parallel,
Yeah.
They are congruent.
what are congruent?
Their angles.
Yes.
Good job.
What type of angles?
Alternate interior.
Very good. Which angles am I going to use for alternate interior? Okay, so the angle at point B and the angle at point D, but I need to name it with 3 letters because there's multiple angles there. But Molly's talking about this one and this one. Not BEC. I mean, I'll talk about BEC in a minute. You said what? ED, not EDC. EBC sounds really good, which I think is probably what you said the first time. So remember, B's got to be in the middle. So EBC if I'm talking about this one. If I'm talking about this one down here, I'd say EDA or ADE. Either one is fine.
Sweet.
What?
Are you doing No Shave November?
I'm doing all right so far. I don't know if I'll make it all month. I get scratchy and uncomfortable. All right. Do you guys want to state another pair of angles off that same logic?
Yeah.
Because we could. So our other angles would be these ones over here, yeah? So then same thing, 3 letters. EAC is congruent to angle ECB.
Yeah.
ECD.
Buffalo chicken dip.
What?
All right, still alternate interior angles. So I don't need to state anything different from that. Okay. I've listed 2 pairs of angles and I had a side. So that's enough, isn't it? I have 2 pairs of angles and a side.
How did angle 9 show up?
It's still there. So how can I prove these triangles congruent?
Vertical angles.
I don't, okay, I actually don't need to put vertical angles. You could, and it wouldn't be wrong. But I have 3 things in my picture already.
Okay, so then,
Good.
what'd you say?
Mallory said ASA. Because we have this angle right here. We have this angle right here. And then we have the side that connects
Oh, yeah, we
them.
have the 2 sides.
So triangle AED,
That's pretty cool.
congruent to
Wait,
triangle.
Instead of doing alternate interior angles,
CEB?
you've done vertical angles?
You have to do at least 1 pair of alternate interior angles. You have to do at least 1 pair. And I just figured let's just do them both. But if you put vertical angles, it's not wrong, but it'll probably change your proof to angle side instead of angle side angle. We said angle side angle.
Good to know.
Wait, can you still use angle angle side?
You could. You have to put that vertical angle though, Molly.
Yeah, I did.
Okay.
I messed up.
This would be. I think we'll have to like use this in real life, like when we like grow up.
No one's going to be like, hey, for this job interview, do a 2-column proof with
I
triangles.
mean, if you're a teacher.
But, that's true. But instead, you'll need to put together like sequential logic steps and apply them to be able to assert something. Like it's like a life skill.
When's the last time they used a proof that wasn't?
Blue collar work.
Never.
Don't use any of this.
No, but blue collar workers do use a ton of geometry. And
They do, because I just find the angles of like the board.
if you don't believe me, I am happy to bring in somebody to guest speak for me.
No, because I saw like this,
My dad's
this
blue
Mexican
collar.
guy at a
Cool.
TikTok account, and he was like yelling out like angles of like the size board that he needed.
Mm-hmm.
And yeah.
Yeah.
I've seen that used on the roof.
Yeah.
Yeah,
Yeah.
From Owen. Now he has to do the angles.
I think we had one like this before. I want to talk about it again. What does it mean if segments bisect each other.
They're both split into 2 equal parts.
They are both split into 2 equal parts. So you get 2 pairs of 2 equal parts, okay? So BC and DE were each split into 2 equal parts. So now it's your job to tell me what are those equal parts.
C, G, G.
Wait.
GE,
G, C.
BG congruent to GC. What's wrong, Carter?
Wait, what'd you say? DC and what else was split into 2 equal parts?
So DE
Yeah.
bisects, so that line
Oh.
and this line, they bisect each other. So they both cut each other in half.
Oh, so it'd be, wait, did you say DG and EG? Or is that not right?
Yeah.
Oh, then the other one would be BG and CG?
Mm-hmm.
Cool.
Definition, segment,
Bisector.
yeah. All right, so I've got 2 sides.
Okay, so now you want to make them vertical.
Okay. So then that would be angle what? Congruent to angle what?
DBG is congruent to CEG.
What is it? Why?
It's my friend. Been since 5th grade.
Oh man. All right. What you said what DGB? You bring him with you everywhere you go?
Why'd you get yourself no room to write?
I don't know. And then congruent to angle.
CGE.
Yeah, I'm gonna do EGC. It doesn't matter though. I would accept either one.
You'll accept it one, but you
No. But so then that would be what? Vertical angle theorem?
Yeah.
Okay, so
And
vertical.
then you just put them,
And then I would say this by what?
Side, angle, side.
Good. Side angle side. Didn't leave myself enough room, but then you would write this statement
yeah.
for my 4th one. Yep. Okay, cool. This one's good. You're just rolling right along, friends.
So hungry. I'm so hungry too. So be my chemistry teacher, then let me go to
How come we never get any hypotenuse length?
How come my math teachers are only...
There's one at the end that I'll show you.
How long do you take that for?
All right. E, F, congruent to H, F. G is
Is
Mid
90% of
PT.
our first exam just gonna be proofs?
no.
I'd cry.
I feel like I got them down.
You're getting them. You're showing a lot of promise, all of you. All right. What is different about this proof compared to the rest?
Triangles.
Oh, it's going to use CP. That's CTC.
Good. And
CP.
how do you know that, Parker?
Huh?
How do you know that?
Because it's... Ooh!
I know why, because the proof is in triangles.
Yeah. So because the fact that it doesn't tell us to prove triangles congruent, it tells us to prove either a pair of sides congruent or a pair of angles congruent. CP, CTC. Good. All right.
Mr. P,
What?
watching the elbow strategy actually works.
Telling you. So I already have a pair of sides congruent. Let's mark it in the picture. EF congruent to HF. And then what? Vocab. What's my vocab?
Do the midpoint.
Doing the midpoint. HG congruent to GE. General Electric.
Then you can do the reflexive.
Definition of midpoint.
Ooh, yeah, definition of midpoint. Got ahead of myself there.
And then you put them reflexive.
FG, right?
You know Oliver's a spy. I still don't understand.
You don't remember tests?
And then
GTA?
you say that
Yeah.
triangles, EFG.
Hold on, too much talking, that's not geometry. We've got those reflexive properties. Okay, so then we have side, side, side. Oh my gosh, now what can I say?
ASS.
Triangle EFG is compared to triangle HFG.
I always said it.
EFG, HFG.
Yeah, then you put SSS and then you put.
Oliver said angle side to side.
Oh, I didn't.
Side, side, side. You've got like 2 more days of that, Parker.
You have to.
All right, I know the triangles are congruent. Now what can I say?
Angle
Good.
H is
Angle H congruent to
CP,
angle E.
wait, CPCTC.
Side note, what does that stand for?
Corresponding, perpendicular,
No.
parallel.
I hear a lot of good things. Corresponding parts, congruent triangles are congruent.
Of congruence.
Are congruent, good. Speaking of congruence, 20 just wants you to write a congruent statement for that triangle. Okay, so if I say triangle, what do you got? QRS.
X, Y, Z.
Congruent to what other triangle? So QRS is congruent to
Y, X, Z.
okay. What are the 6 methods we use to proving triangles congruent?
SSS, SAS, ASA, AAS, hypotenuse plane.
Good. What's the last one? No.
No.
Angle.
We do have to mention HL. What's the last one? What's the 6th one? Not CPCTC.
Oh,
Not SSA.
congruent.
Definition of congruent triangles
What?
is the last one. Yep. Yeah.
ASA, SSS, SAS, AAS, HL, and definition of congruent triangles.
Correctamundo, definition of congruent triangles. That came out of section 4.3. That's where you had to show all the pieces, all the angles, all the sides are congruent. Okay. All right.
Wait, then what's CPCTC then?
That's a great question. So Alina asks, okay, so what's CPCTC? We use that after we prove the triangles are congruent. So if you look in that proof that we did, right? We did side, side, side here, and then we used CPCTC. I didn't hear you because Parker made that noise. Stop. What'd you say?
So is that to prove that like the angles or the sides are the same?
Exactly. You,
CTC.
yep, you use CPCTC to prove one pair of pieces, whether it's sides or angles. No, I didn't plan on it.
Dang it.
Sorry. 2 invalid methods.
Look at all the writing I've done. That looks really nice.
Yes. What are the 2 invalid methods?
ASS and AA.
Good.
And Parker Sagers.
All right.
ASS is like.
The only proof that I want to do of the last page is probably the first one. I can talk about the other ones. Happy to do that, but I want to do the first one. For sure. Faux show. For real. All right. AB is congruent to DB, and then those lines are perpendicular to each other. Now what? Got to use perpendicular. Perpendicular lines give us what?
Right angles.
Right angles. So I'm going to say ACB, angle ACB, comma, angle DCB are right angles.
And then you do reflexive. Then you do HL.
I like it. So definition of perpendicular. And then Parker said, okay, you've got right angles here. You could do the reflexive side. How did you know to use HL? Because like last time, Parker, when we knew they were perpendicular, we stated they were right angles, and then we said they were congruent, and we did like angle side angle. Why do you want to use HL with this one? You're right, but why? Do you know what was different about this one compared to the other one?
No, I wasn't paying attention to it.
Okay. The difference is, with the other one, we didn't have the hypotenuse congruent. With this one, they gave us the hypotenuse congruent. So I've got hypotenuse congruent, I can get a pair of legs congruent, and then I have to state that they're right triangles. So I can say those three things, okay? So far, I've done none of that, but that's fine. I got a lot of steps that I'm gonna write. I'm gonna run out of room. So from here, like once you state that they're right angles, you're either gonna state that those angles are congruent to each other, or you're gonna state that the triangles are right triangles. Since Parker said we need to do HL theorem, which route do I take? Right triangles. I need to state that they're right triangles. That's the other piece of HL theorem. I'm gonna recopy the exact same statement I have for 2, but everywhere there's an angle, you're gonna write a triangle. And then it'll read triangle ACB, comma, triangle DCB are right triangles. Anybody know the reason for that?
Definition of right triangle.
Good job, Alina. Okay, I have stated one of the 3 things I need to state, and I have no room. That's fine, we can overcome. Parker, you said reflexive side.
Yeah.
So BC is congruent to BC.
Why BC? Is it because it's perpendicular or the line in the middle?
Because it's reflexive. That gives me a pair of legs. That reason is reflexive property. All right, and then up here, I actually did already state my hypotenuse is congruent, so that's good news for the good guys. So I stated hypotenuse is congruent, I stated my legs were congruent, and then this part is the tricky part about HL theorem, is stating that the triangles are right triangles. We've done all those. Now I would write my proof statement, and then HL theorem would be my last one. So you would do triangle ABC, congruent to triangle DBC, HL. And that would be step 5. I don't think I need to do number 2. Let's talk about it though. Tells you those angles are congruent, tells you those sides are congruent. What's your other piece you'd get? Vertical angles. And then what technique would you guys use? Good job, Mallory. That side doesn't connect the 2 angles. Good. 3, GK bisects both of these angles. So that's congruent, that's congruent. What other piece could we say? The reflexive side. What would that be? ASA. Very good. 4, you said what?
What was the other angle?
It says GK bisects both of these angles.
Yeah, but what's
So you get 2 congruent parts out of this one and out of that one.
what's the other letter?
Oh, I'm sorry.
Is it just not supposed to be one?
It's F. This is F.
Oh, okay.
The picture just got cut off. So it's F. 4 requires you to do segment addition postulate. Not going to make you do it on the test.
That's a lot.
That's a lot. That's big. All right, questions on the review? Let me give you your quizzes back. Sam, you got to remove yourself from the room. You may go to the restroom. You may rest in the room.